Okay, when you pick up these units, it's very rarely you'll actually get all the connectors for various bits and pieces. Some of them are easy to get hold of, or reasonably easy to get hold of, like the multi-pin here. I've seen this one used on things like the Larkspur equipment, the R210. I'm sure various other ones. It's basically a multi-pin circular one. You can move the insides around to fit various items. But some of them, like I've not been able to find the type W connectors for the power, the 2-pin or the 6-pin for the microphone, headphone type things. Just the unit. So I try and build my own type of plug and sockets as temporary measures. So using paper to line the bottom of this socket and the ring, 2 brass bits of tube that will actually fit and grip onto the actual plugs, then fill it with hot glue. Similar thing for the 6-way connector, line it with paper, find some sockets that will, crimp sockets type thing, that will fit over the pins, solder or fit the wires to the pins, put it all into position, and then fill it with hot glue again. So it does at least mean to say I've got a method of connecting onto it. The wave connector, that was the antenna, I changed it for a BNC because again I cannot find the correct plug for that one. The power supply I'm using at the moment is a PS112 made by Plessy, which is a type of regulation, although it's not what I would call a regulated power supply by any means today. With no load on it at all, it gives 40 volts output, but you start drawing current on it and it will regulate of sorts down to around about 27-28 volts. So I'm using one of them that's capable of quite a few amps, and unfortunately I don't think this one's behaving quite as it should do. It's got quite a bit of ripple on the output side, but it's enough to actually drive this thing as a means to actually try it. So I've got a 128 ohm speaker on the output which is simulating the headphones. I've got a switch to do the PTT, and I've got 2 wires here. That would be the audio input, the microphone input, normally which would be balanced input, but I'm going to drive that from the mod out, an internal output from my radio test set, the old IFR. Channel change and switch on is done by this. It's just a rotary wafer switch with 2 sides of it, one of them to do the on off and the other one to do the channel position. So it's going to get quite noisy. I'm going to move this wire out of the way and prop it back out of the way here, so hopefully you'll be able to see this rotating as it does the channel change, and the actual switch positions move in and out as it goes through each channel. Right, as I say, this will be noisy. Channel 1, channel 2, 3, 4, 5, 6, 7, 8, 9 and 10. If I want to go back to 1, I've got to go through all the sequence to go back to 1, 2, 3, 4 and 5. I want to go back to 4, back to 4. So there we have it. That's the as I said, quite noisy. The noise obviously generated from the rotary transformer on this side. And again, what's actually happening, if you can see, let me just drop the camera a little bit. Hopefully you can see this section here. Power it up, you'll see that it doesn't turn. Not turning, but the rotary transformer is going all the time. The fan is going in there and forcing that around the inside of the case to cool the valve. But when I change channel position, the coil would come in, activate the channel change. There's channel 2, 3, 4, 5, and back down to 1 again. So that only moves on channel change. And when you take power off, it keeps on moving. Right. It is noisy. I do apologise for that, but what I'm going to do now is put the case on it to try and keep the noise down, and just show you a bit of transmit, bit of receive. Okay, what I'm going to do now is show it on transmit and receive. What I've done is I've got it connected to the test set antenna socket. I've got a scope across the speaker, because I don't really think you're going to hear it, but you should be able to see it on the oscilloscope trace here. I'll turn that up a little bit more so it's up on full, so you can see it when it comes on. And this is my signal level. I say quite a def set this, but it'll give us some indication. I've got a crystal in that will put it into the 2 meter armature bands, but it's still on a dummy load. So I'm making sure I'm not doing anything untoward I shouldn't do, and certainly not going to play on any of the aircraft bands. It is AM, and when it comes to the transmit side, I'm going to use the audio output from this thing to drive the microphone input, because I say I've no microphone for it, but we should be able to see a level of AM on there. I don't think it's going to produce the 100% AM. I need to change too many capacitors and other various bits and pieces to get it to do that, and I really can't see a point apart from the interest to make sure it does transmit and receive. So here we go, let's get it powered on, switch it on to channel 1. And as it comes up, the valves heat up. As you can see from here, hopefully, that's the covered audio, increases and decreases with signal level. You might be able to actually hear that tone coming through. So that's the receiver side, working your salts. Just try and show you, if I move the receiver trim pot, that's the tuning control on the front, that's locked in by the cams. I can force it out a little bit, but that's the receiver tuning. I'll switch it over to transmit. Hopefully you saw this control. Again, I've got a transmit tuning here, like an effect. The transmit side, there we go. About 4.5 watts now, leave it like that. I shall now put some mod on. I shall take a scope probe, connect it to one side of the modulation input. Forget that side tone coming back out of the, but hopefully here now on this side you'll see the AM envelope, so that's no mod, that's with mod. So it's probably doing about 60-70% modulation and about 4.5 watts output. Quite a noisy radio. I guess on the aircraft the radio would be somewhere else other than where somebody's going to listen to it, but it's quite a noisy, and probably quite possibly why it wasn't popular. Turn it off. Probably why it wasn't quite popular on the amateur band type things when it first came into the amateur market as surplus. I'm guessing around about 1980s it would have turned out to be on the surplus market. There's no labels on this one saying what date it actually was. I'm guessing because it's a wide frequency range, it was towards 1960 when it was actually produced. I'll have a quick look on the inside, see if there's any date stamps on any components. Just looking around the set for any date codes here on capacitors, I've not found anything obvious. But the only thing I have found, and hopefully it's in view, is a sticker here, R. I don't know if that's because it's been in the repair centre, been refurbished or whatever, but I'll imagine this is dating it towards the end of its life when it was taken out of service and seeing if it was still working. Or we have a label here, paper label with an R, looks like T5R or A5C, and it's dated March 1983. So I suspect this came onto the market shortly after that type of thing, being taken out of service, replaced with something else. On the back panel here you can see that's the input from the air filter, so that's where the air goes in, gets blown around the chassis and comes out on this side. Markings on the back of the thing to say what all the valves were. Basically this was bought to strip it down for parts, but I always find it of interest to see if it will work, and I shall try and put out a few more videos in the near future without such a delay. Thank you.